Today we want to have our period about matrices. We definition, a matrix is defined as a set of numbers arranged in a form of rectangle consisting of rows and columns. If you want to explain this, means that this we form it as this. This is the rows here, this is the rows, and this is the columns. So in form in columns, these columns, we call these are rows and these formed as a columns. So if the matrix has m rows and n columns, its type is mn, m dot n. When the numbers of rows equals numbers of columns, then it calls a square matrix. It means that the numbers of rows here, from example here, we have 3 rows and 3 columns. In this case, we call the matrix is square matrix. It means that we have 3 rows here and we have 3 columns here. This means that the square matrix. So when the numbers of rows equal the numbers of columns, in this case we call, and the columns of the matrix consist numbers. These numbers are called the entries of the matrix or the element. So we call it the entries of the matrix. It means that this element, we call it the entries. These entries are called the element of the matrix. This is the element of the matrix. Okay. Example for matrix. Generally we name the matrix by capital letters. We call the matrix by capital letters. It means that this matrix A contains 2 rows and 3 columns. This matrix B contains 2 rows and 2 columns. Dimension of the matrix. This is the dimension of the matrix A 2, 3. It means that the dimension of the matrix is 2 times 3 or 2, 3. This dimension of the matrix 2, 3. This dimension of the matrix is 2 by 2. So when I write the numbers of that written at the end, the end of the right side, the end of the right side of the numbers, we call it the dimension of the matrix. It means that this matrix, it is dimension of this matrix is 2 by 2 or 2 by 3. Dimension of the 2 by 3. So we call this dimension of the matrix or the size of the matrix or order of the matrix. AB, it means that this matrix it is ordered AB or it is size AB. Or it is order AB or dimension AB, where A indicates the numbers of rows and B indicates the numbers of columns. In this case, when we say return back to this matrix it is of dimension 2 by 3. It means that it contains 2 rows, these 2 rows and 3 columns. So we can write this matrix in column of A 2, 3, the dimension of this matrix. Okay. In general, matrix consists of m rows and n columns. Can be written in this form AMN. It means that these are numbers of rows. And these are numbers of rows. It means that this is the first row, this is the second row, this is the third row, up to n rows. This matrix contains m rows and n column. This is the first column, this is the second column, third column, fourth column, up to n column. So the last element of this matrix is AMN. For example, also can be Mn. It means that this matrix contains m rows and n columns. B11, B12, B13, B14 up to B1n. This is the first row. The second row is B21, B22, B23, B24 up to B2n. The last one, the last row of this matrix is BM1. This is the first column. The second column is BM2. The third column is BM3. Up the last one is BMN. So I call this the last element of this matrix. Okay? This matrix A33, A11, A12, A13, A21, A22, A23, A31, A32, A33. This matrix B23 means that contains 2 rows and 3 columns. B11, B12, B13, B21, B22, B23. Okay. Some special type of matrix. We we have some type of matrix. Row matrix. This matrix consists of only one row. It means that consists only one row but many columns. It means possible 2 columns, 3 columns, 4 columns, doesn't matter. But it is contained one row. In this case, we call this matrix the row matrix. For example, this A13, it means that contained one row and 3 columns. A11, A12, A13. Also, we have column matrix. This matrix consists of only one column and any numbers of rows. A31 contains 3 rows and 1 column. A11, the second row, A21, the third row, A31, but it contains 1 column. So we call this matrix column matrix. Also, we have another type of matrix, zero matrix. This zero matrix, it is matrix that all its entries are 0. I mean that all its elements are 0. Doesn't matter if it became or row matrix or column matrix, or square matrix, or this square matrix 2 by 2, and this square matrix 3 by 3. But its entries are zeros, 0, 0, or these zeros, these zeros, these zeros. This matrix call it zero matrix. Diagonal matrix. It is matrix. Diagonal, it is square matrix. It means that any diagonal matrix, it is square matrix. This matrix, where it is entries are 0, AIG, all the entries are 0 except it is principal diagonal are non-zero. Non-zero. Means that A to do this, A to do it means that has 2 rows and 2 columns. These 2 rows, 2 columns, all the elements are entries except this principal diagonal. I mean by principal diagonal, this one. This is principal diagonal. The principal diagonal is 5 and negative 9. But this is 0 and this is 0. This is 2 by 2. This is 3 by 3. Principal diagonal is 1, 8, 11. But the remaining entries are zeros. This is called diagonal matrix. Any form of this diagonal matrix, any form of this matrix, it must be the matrix is called diagonal matrix. It must satisfy. First of all, it must be square matrix. Secondly, it's the diagonal principal is equal to non-zeros, and the remain entries are zeros. Unit matrix, or it's called identity matrix, it is diagonal matrix. So a unit matrix is diagonal matrix. Since a unit matrix is diagonal matrix, it means that this unit matrix it is square matrix first, and all its entries are zeros, except it is diagonal. It is a diagonal principal diagonal. Principal diagonal are equals equal 1. It means that these principal diagonals are 1, 1, 1, 1. Any matrix in this form is called unit matrix or identity matrix. This called identity. This 3 by 3 matrix and this 2 by 2 matrix. This identity matrix and this identity matrix. So if I want to define a unit matrix, it is a diagonal matrix. Since it is diagonal matrix, it means that it is square matrix. Since it is square matrix, this square matrix means that the numbers of rows equals the numbers of columns. And the principal diagonal are ones. It means that are equals are equal 1, 1, 1. If the principal diagonal are 5, 5, 5, this is matrix. Also, I can call it unit matrix, but it's multiplied by 5. If I multiply by 5, it becomes unit matrix. If I divide it by 5, it became unit matrix. Okay. We have some examples. Write the dimension of this matrix. A 4, 2, 9, 0, negative 1, 8. Matrix B 5, 6, 9. This is the entries of CB. This is the root of C. So we find that the dimension or the order of this matrix it is 3 by 2. This matrix it is 3 by 3. So the dimension of this matrix is 3 by 3. This is 2, 3 by 2, 3.2, and this is 3.3. And this is 3 rows and 1 column. It is column matrix. Its dimension is 3 by 1. From above, from this example, from above find the value of the entries. A11. A11 it means that the element that lies on the first row and the first column. The first row and the first column, this is the first row, and this is the first column. Then the section of this line, 4. So A11 equal 4. A12, it means that the element that lies at the first row and the second column. This is the first row, and this is the second column. So the intersection of the two lines are 2. So A12 equal 2. A21, it means that the element that lies at the second row and the first column. This is the second row and this is the first column. So A21 equal 9. A32 means that the element that lies at the third row and second column. This is the third row and this is second column. It means that A32 equal A. B22, the element at the matrix B, such that lies at the second row and second column. This is second row and this is second column. Therefore, then A B22 equal 2. B12, it means that the element that lies at the first row and the second column. This is the first row and this is the second column. The intersection of two lines is 6. So B12 equal 6. B23 means that the element that lies at the second row and the third column. Second row, this is the second row, and third column, this is the third column. So the intersection of the two lines at N. So B23 equal 8. B33 means that the element that lies at the third row and third column. B33 equal this third row, this third column equal 11. So B33 equal 11. And so B31 and B2 are the same one. So if we come to C, the matrix C, C21, it means that the element that lies on the second row and the first column. This is second row. And this is second. This is second row and the first column. You see that this matrix, it is column matrix. So it contains one column. So this is equal 3 by 2. 3 by 1. Sorry, 3 by 1. 3 1. This 3 1. 3 1, 2 1, it means that the element that lies at the second row and the first column. We have only one column. Third row, it means that negative 1. Second row, negative 1. This element lies at the third row. Third row equals 33. We come to the equality of two matrices. We say that two matrices A, B, A is matrix, B matrix, are equal if and only if. If and only if the following two conditions are satisfied. The first condition for two matrices are said to be equal if it satisfies they have the same dimension. It means that the dimension of A equals the dimension of B. The size of A equals size of B, or the size of A equals size of B, order of A equals order of B. Their corresponding elements are equal. The corresponding elements are equal. It means that the elements that lies at, it means that A11 equal B11, A23 equal B23, A34 equal B34, and so on. Aij equal Bij for all possible values of Ij. Then we write that A equal B. For example, if we have this matrix A equal this matrix 2 by 3, 2 by 3, and B is matrix 3 by 2, C it is matrix 2 by 3. So which of these matrices are equals? We find that if he says that A equal B, no, it's not satisfied the first condition. Why? Because A, it's in the A dimension of A equal 2 by 3, but dimension of B equals 3 by 2. So 2 by 3 not equal B by 0. So this A not equal B. Why? Because it doesn't satisfy the first condition. Okay. What about A and C? A equals C. So we can check the dimension. We find dimension of A 2 by 3 and dimension of B of C 2 by 3. Okay. This is the first, it is satisfied. What about the second one? The second one, the corresponding elements are equal. It means that any element here, the corresponding element here equal here. We have A11 equals C11. Okay. A12 equals C12, 3, 3. A13 equals C13 equal 5. A21 equal 8. C21 equal 8. A22 equal 7. C22 equal 7. A23 equal 6. C23 equal 6. So it satisfies the two conditions. In this case, we say that A equals C. So why A equals C? Because it satisfies the two conditions. They have the same dimension and the corresponding elements are equal. Okay. Example. If A equal B, he said to me A equal B. Since A equal B, it means that A and B are from the same dimension and the corresponding entries are equals. Okay. If A equal B, where A equal X, 3, negative 2, Z. And B equal 5, 3, Y plus 1, 8 minus 6X. Find the value of XY. Since A equal B, it means that this for the dimension of A equal 2 by 2. Dimension of B equal 2 by 2. So, since this satisfies the first condition, the second condition, it must be equal. 5 equal X. This means that 5 equal X. What I here I have 3 and here I have 3. Y plus 1 equal negative 2. So we have to make this equation in order to find the value of A. Okay? Y plus 1 equal negative 2. You transform negative 1 to the other side and change the sign. So y equal negative 2 minus 1. Therefore, y equal negative 3. We find that x equal 5. What about z? We have x, a minus x equal z. Since x equal 5, we have to substitute the value of x here. So a minus 5 equals z. When you subtract 5 from 8 equals 3, 3 equals z. So therefore, z equal 3. So x, y, and z equal 5, negative 3, and 3. If you have another example, if A equal B, where A equal to x and negative 5, 3x plus 4z, 7x minus 8z, 5y plus 12z, and B equal 9z minus 5x plus 1, 5y minus 2x, 3y minus 4z, and 12x plus 2. Find the value of x, y, and z. First of all, you have, since this A is dimension 2 by 2, and B is dimension 2 by 2, so the corresponding values are equal. Means that 2x minus y equal 9z minus 5x plus 1. 3x plus 4z equals 5y minus 2x. 3y minus 4z equals 6x minus 8z. 5y plus 12z equals 12x plus 2y. So we made 4 equations. 4 equations from the its corresponding 4 elements by using simultaneous equation to change these values to equation, and after that to solve this equation. 2x minus y equal 9z minus 5x plus 1. If we make this equation, to solve this equation, the first equation is 2x minus y equals 9z minus 5x plus 1. By make all this equation equal 1 to create the unknowns in one side and the knowns on the other side, transform 9z to this side and negative 5x to this side, means that 2x plus 5x minus y minus 9z equal 1. 2x plus 5x equals 7x. This means that 7x minus y minus 9z equal 1. By the same manner, 7x minus 8, 7x minus 8z equals 3y minus 4z. When we change 3y to this side and 4z to this side, it becomes that 7x minus 3y minus 4z equals 0. Sorry? 2x plus 7x minus 8z equal كده. Okay. The third one 3x plus 4z equals 5y minus this second equation minus 2x. So equal what? 2x to get the other side. 2x plus 3x equal 5x. 5x. Negative 5y. This 5y here when I change it to the result other side. Negative 5y plus 4z equal 0. The last equation 5y plus 12z equal 12x plus 2y. This 12x. If I change 5y to the other side, it became negative 5, means that 12x minus 3y minus 12z equals 0. So this is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. You solve these 4 equations simultaneously. How? You have to eliminate either y. If I want to eliminate y here, you have to multiply this by. If I add, subtract 2 minus 3, 2 minus 4. 2 minus 4, it means or 4 minus 2. 4, equation number 4, minus equation number 2. 12x minus 7x equal 5x. Equal 5x. 12x minus 7x equal 5x. Negative 3y minus 3y, it means that negative 3y plus 3y, it vanish. Negative 12z plus 4y, this is negative 8. Z equal 0 minus 0 equals 0. Put this equation number 5. From this, if I multiply this equation by 5, I want this, divide this by 5. This equation by 5, it means that subtract this one by this one. Divide is 5. This is 35. Z, 35x. 35x. 35x, it means that 35x minus 45 minus 5y minus 45 z equal 5. So if I subtract this equation, put this equation 6 by 6, subtraction 6 minus 3 means that equation 6 minus equation 3 it become what? 35x minus 5x equals 30x minus 5y plus 5y, it vanish. Minus 45z plus 12z, it became 33z. Minus 33z equal 5. Okay. If I want to solve these two equations, multiply this equation by 5 by 6, so and subtract and add on subtraction. This by 6 equal 36, 30x minus 48z equals 0. By subtraction, this is negative, this is positive. This vanish. 33 minus 48, you will find the value 33. Okay. Sorry. 2x minus 2x minus y equal 9z minus 5x plus 1. This equation equal, if I change 9z to other side and negative x to other side, 1 remain at its place. So you find that 7x minus y minus 9z equal 1. This is the first equation. The second equation, I transform 5y to other side and negative 2x to other side. It became 5x minus 5y plus 4z equals 0. Also, you change you transform 3y to the other side and negative 4z to the other side, it becomes 7x minus 3y minus 4z equals 0. The last equation, 5y, if I transform this to the other side, it means that 12x plus 2y at this side, 5y became here negative, so 2y minus 5y equals negative 3y. 12z became this side negative 12z equals 0. By solving these four equations simultaneously, you find that this 7x, the first equation, 7x minus y minus 9z equal 1. The second equation, 5x minus 5y plus 4z equals 0. The third one, 7x minus 3y minus 4z equals 0. The last equation, 12x minus 3y minus 12z equals 0. This is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. To solve this equation simultaneously, it means that you have to eliminate either x to this equation, put it in terms of two unknowns. If I want to put this equation in two unknowns, for example, x and y. If I add 4, equation number 2 and 3 to eliminate z, 5x minus 5y plus 7x minus 3y equals 0. By 5x minus 5y. 5x minus 5y, this vanishes. 5x plus 7x equals 12x. Means that by adding 2 plus 3, means that equation 2 plus equation 3. 5x plus 7x equals 12x. Negative 5y, negative 3y, negative 8y. Plus 4z minus 4z equals 0. This means equals 0. This is equation number 5. Okay. For this equation, if I want to eliminate z for this equation, multiply this equation by 3. Multiply this equation by 3. If I multiply this equation by 3 times 5x equals 15x. This equals 15x. Negative 15y plus 12z equals 0. Or you can return back to this one. This one. 15x. Okay. If I return back to this one, this 7x minus 5 minus y negative 9z equal 1. If I multiply this by 4 and this by 3 on subtraction, this became that 4 times 7x equal 28x. 4 times negative 5 minus 4y minus 36z equal 4. The last equation, multiply by 3. This 3 times 12 equal 36x minus 9y minus 36z equals 0. By subtraction, subtract this minus this one. 36 minus 7 minus 28x equal 8x. 9x minus 4 means that plus 5. Plus 5y equal negative 4. This one. 36 minus 28 equal 8x. Negative 9 minus 4y equal negative 5y, sorry. Negative 5y equal negative 4. This vanish equal negative 4. This equation, if I want to solve this equation by this one, this I have 12x minus 8y equals 0. Multiply this by 8 and this by 5. 8 times 8x, 64. x minus 40y equal negative 32. This is 5 times 12 equals 60. X minus 40y equals 0. By subtraction, this minus this one, or this one minus this one. 64x minus 60x equals 4x. 40 negative 40y plus 40y vanish equal negative 32. By dividing both sides by 4, this by 4, therefore x equal negative 8. So you find that here, x equal negative 8. By the same manner, if I substitute the value of x here, the value of x here, x equal negative 8. 8 minus 8 equal 8 times negative 8 equal. You find that you can substitute the value of x here and find the value of y. You find that x equal negative 8, y equal negative 12, and z equal negative 5. So we go to another section of matrix, transpose of matrix. If B is Mn matrix, means that the dimension of B is M by M matrix, then the transpose of B is an Nm matrix. You have to change the numbers, the columns became rows and the rows became columns, matrix. It is rows respectively are the columns of B, and it is denoted by BT. B, if B is Mn matrix, then transpose of B is an Mn matrix. It is rows respectively are the columns, and the columns respectively are the rows. Means i.e. The transpose of B, it is B denoted by BT. Example, if A equals the matrix 2 by 3, it is dimension, it is element are 5, 6, negative 8, negative 1, 3, 9. Then A transpose, you have transpose A transpose equal, you have to change the row, this 0, it became column, and this 0, it became column. So A, the transpose of A equal 5, negative 1, 6, 3, 8, 9. This is the transpose of A. Now if A, the matrix A equal A to port is the matrix A equal A transpose, such that as below, A equals 3, the matrix A is 3, 55, 9, 55, 2, 3, 9, 3, 1, and the transpose of A, it is 3, 55, 9, 55, 2, 3, 9, 3, 2. It means that A equal A transpose. In this case, we say that A is a symmetrical matrix. I.e., if any matrix is equal, it is transpose. In this case, we say that A is a symmetrical matrix. So the symmetrical matrix, we say that the symmetrical matrix, if it is equal, it is transpose. Find the transpose of each of the following matrices. A, 3, 6, 9, negative 5, 7, 1. Which of them is symmetrical? This matrix. Okay, if you want to find it, and after that, how to allocate the symmetrical matrix, or how to define the symmetrical matrix from them. Matrix A equal 3, 6, 9, negative 5, 7, 1. Therefore, A transpose equal. Change it. This row became column 3, 6, 9. Here negative 5, 7, 1. This dimension 2 by 3. Dimension of this 3 by 2. So this is A transpose, T does equal A transpose. So this is not symmetrical matrix. What about 2? The second matrix 1, 0, 0, 1. The transpose, if this B, so B transpose equal 1, 0, 0, 1. So in this case, B equal B transpose. So this is symmetrical matrix. What about the last one? C equal 5, 8, 2, 3. Therefore, C transpose equal. The transpose of this one, 5, 2, 8, 3. A11, C11 equal 5. Transpose of C. This is the first element equal 5. But the last one, the A12 equal 2, but here equal 8. So C not equal C transpose. In this case, this is not symmetrical. We said that the matrix is said to be symmetrical if it is equal, it is transpose. And C equals C transpose. In this case, we say the matrix is asymmetrical. So we come to the end of our period. Thank you.